Hello, everyone. Thanks for everyone who showed up in the demonstration and gave Meeting Zoom a try. For those who haven't, this is the problem we're trying to solve. Imagine that you're in a video conference with 10 other people sitting in the same table, and that you had prepared a very important thing to say last night, but you're just a tiny dot on the screen, so you don't have really that much importance, or at least it doesn't look like it. What Meeting Zoom does is it makes your life easier. It just zooms at you, so people can focus on the things you have to say. And this is how it works.
Yeah, so the way we do this is we combine two different sources of input. We have video data from a wide-angle camera, and we have stereo audio data from a pair of microphones. We use the video data to perform face analysis to detect where the faces are in the scene. Then we use the audio data to work out where the sound is coming from. We then match these together to work out the face which we should zoom in on, and we perform this zoom smoothly on the video and output this to a virtual camera, which can then be used in other video conferencing applications such as Skype. So the way the audio analysis works is that when you have the two different microphones, the source of the audio has a slightly different distance to both to each of the microphones, and so there's a phase difference in the audio signal. We compute this phase difference using some algorithms and use this to work out where the angle of the audio is coming from.
And to do the face detection, we used a pre-trained neural network on 300 by 300 images. So we split the image up into segments and merged the results. This was slightly problematic because it could only detect some faces every other frame, for example. So we added an inertia to the frame face detection to smooth this out. Also, if someone were to look at someone to talk to them, it could lose their face. So we made it persist a couple of frames. Yeah, and as Sean was saying, we matched up the audio and the video. It's audio driven, so we detect when someone is speaking and then try and match that to a face.
Okay, and about the user interface, this is how it looks when you use it. It's very simple. You have an on and off switch. You choose the microphones and the input camera. Of course, this was not sufficient in the development phase because you can't really see how the decisions are taken. So what we actually used is a separate debug UI, which allowed for useful overlays and change of parameters. This is how it looks. So basically, the upper image is the debug one. The red rectangles are the face recognitions. The blue rectangle is the zoom area. And you also have audio lines for where the audio is coming from. You can see the result on the bottom. You can also see that we can modify some of the configurations. So what we wanted to do is to make Meeting Zoom portable. And we don't want to bind it to some specific application. For example, Skype, we want it to be usable with everything. So what we did is export a virtual camera that can be used in any application. And from the point of view of this application, this is just like a separate video device. How we did that is with the help of a loopback driver, to which we can just supply the frames we want to export to this camera, and then every application can use them. So we've thought about a few possible extensions. One of them is to train the model on heads, because right now it's, yeah. We can also subtract the background. We can have more microphones for a better evaluation of where the audio is coming from. And we are also, we can try this to make it cross-platform and work for Windows as well. Thank you.